For number 8, we're looking for a linear function. So think y equals mx plus b, the equation of a line. And it tells us that x is going to be the size of the container, and then our y would be the time. So time equals mx plus b, where x is the size of the container. It gives us some data here. So plug in the y and the x values, or the t and the x values. 27 seconds goes with that size container. 12 seconds goes with that size. So plug all that in. Now just subtract these functions, these equations. This equation, subtract that one, and you're left with that. So you can divide both sides by 660, and I don't know why I have an x there. Divide both sides by 660, and m is 1 over 44. So we solved for m. The only other thing we need to solve for is b. And so plug m into either one of these equations, it doesn't matter which one, and then solve for b. I plugged it into the top one. When you do 1 over 44 times that number, you get this, and then subtract 28 from both sides, and you get what b should be. So time equals 1 over 44. We solve for that, and b is minus 1. So that's our linear equation. For number 9 here with the graph, you're just looking at the end behavior. So what does the graph look like as it goes towards the end on the negative side? And it looks like it's shooting upward towards infinity. And then towards the end on the positive side, it's shooting downward towards negative infinity. So look at our option choices here. All we need to look at is a leading term. If the exponent is even, so choices A and B, it means the ends go in the same direction. So if this end's going up, then over here, it should be going up as well. So that's why A and B are clearly wrong. Now, B would mean it has a positive number in front, so they both go upward. A has a negative number in front, so the graph with both of them would be going downward. Excuse me. So it's not A or B because they go in opposite directions. But C here and D both have an odd exponent. They have a 5 here. So that means they go in opposite directions. And the answer is D. And D looks like this, where when you're going on the positive x values, it goes downward. And then when you go this way to the left, it goes upward. And that's because you have a negative in front of the first term, a negative 2. If you have a positive first term, so just a positive x to an odd exponent, this side should be going up, and this side should be going down. So you don't need to solve anything with this. You just need to look at the very first term, and it'll tell you which of these is the correct equation. You mentioned on the phone domain and range. Excuse me. Domain is all the x values that exist on the graph. So I'm just going to use number 10 here to illustrate this. If you go to any x value, there's the graphs associated with it. Like at this x value, here's the graph. When x is 0, the graph's right here. As we keep moving, you can look at any x value, and there's a graph there, except for right here at 2, and that's why we draw this dotted line, is to show that the graph gets closer and closer to 2, but 2 is not, when you get to the x value of 2, the graph doesn't exist there. There's a hole. And then on the other side of 2, you can see any x value you pick, yeah, the graph, there's a line there, the graph exists. So the domain would be negative infinity all the way to positive infinity, except for the number 2. So all numbers except for the number 2. The range is the same concept, but with the y values. So you're looking at these y values. Well, up here there's no graph. Okay, we're looking in this direction now. Is there any... The graph's all the way down here, so there's no y value of 4 ever on the graph. You look out, the graph never gets up to 4. It never gets up to 3. It never gets up to 2. It gets all the way really close to 1. Again, that's dotted line means it never quite gets to 1. So the domain is everything from negative infinity, because you can see the graph keeps going down, 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 down. Everything from negative infinity all the way up to the number 1, but not including the number 1 because it's just not quite there. So that's your range, negative infinity up to 1. This one actually asks for domain and range. Well, which x values have anything associated with it? I know we can only see a little bit of the graph, but it keeps going on forever and ever. So eventually it'll spread out, and any x value you want, possibly in the world, will be associated with the graph. There's no holes, there's nothing stopping you from choosing any x value. So the domain is negative infinity to positive infinity, all the x's. And you can see, you can't imagine a number you could put in here and it would give you an error back or something's wrong. So that means every number works from the domain. You can put any number in the world you want in here, subtract 4, square it, and minus 2, and get an answer. So every number is from the domain. Now the range, if you look at y values, yeah, 8 has a couple y values on here, 6 does, but once you get down here, there's nothing associated with these negative numbers. So the domain is negative 2 all the way up to positive infinity. Those are the only y values that are results on the graph. I jumped to number 40 just to do one last thing with domain. If you have an equation, like I said in that last one, any x number you should be able to plug in and get a result. And when you can't get a result back, that's why it's not in the domain. When you plug any x in here, there's no problems unless you plug in a 3 or a negative 3. When you plug that in, you get 9 minus 9, which is division by 0. You get 3 divided by 0 if you plug in a 3 or a negative 3. And you can't divide by 0, so the domain is everything from negative infinity to positive infinity except for these two numbers. And that's why the graph has these gaps here, these jumps, is because at 3 and negative 3 we never get an answer when we plug in 3 and negative 3. And the range for this would be negative infinity to positive infinity, except for 0. We never quite reach 0. You can see these things get closer and closer to 0. This one gets close to 0, but we never quite hit 0. And again, you can, there's no x number you could plug in here to get the answer of 0. This side can never be equal to 0. Because 3 divided by something, it's not going to be 0, it's going to be some number, but it won't be 0. So 0 is never an answer, and that's why there's a gap at 0. For graphing questions like these, look at the book on page 614. This tells you how to quickly identify whether it's a parabola, circle, ellipse, or hyperbola. And so if you just had all the numbers on one side, you can tell by this criteria which one of these it is. And then continue on the next page, it talks about how to graph it. So that would be something good to write down on your note card.